You know, I want you to imagine something with me. And I mean really imagine it. Not just as an idea, but as if you are actually there. You're floating inside a spacecraft, far beyond anything you've ever known, so far from Earth that the idea of home already feels a little abstract, like a memory that's slowly losing its sharp edges. And outside your window, there it is, Saturn, a pale yellow giant hanging in the darkness, surrounded by rings so vast and delicate that they don't even look real, like something drawn by an artist who didn't care about the rules of physics. And at first, if you're being honest with yourself, you'd probably feel a sense of awe, maybe even excitement, because you've made it farther than almost any human ever has. You're looking at one of the most beautiful objects in the entire solar system. And for a moment it feels like a victory. But here's the part I want you to stop and really think about, because this is where the story changes in a way most people never consider. You didn't just arrive at Saturn. You crossed a line, not a visible one, not something marked by a sign or a warning, but a very real boundary written into the laws of physics themselves. And the moment you crossed it, something fundamental changed. You're not just visiting anymore. You are committed. See, most people think of space travel the way they think about trips on Earth, or even flights across continents, where the hardest part is getting there and coming back is just a matter of turning around. But space doesn't work like that. And Saturn is where that illusion completely breaks down, because out here, distance is not just distance. It's energy, it's time, it's survival. And every kilometer you travel away from Earth is not just a step forward. It's a step deeper into a situation that becomes harder and harder to reverse. Now I want you to consider this from a different angle. Imagine you try to leave, not dramatically, not in panic, just calmly, logically, like any reasonable person would do after completing a mission. You fire up the engines. You calculate your trajectory. You point yourself back toward that tiny, almost invisible dot where Earth used to be. It sounds simple, doesn't it? Just go back the way you came. But this is where intuition betrays you, because the universe does not care about what feels simple. It only cares about what is possible. And what's possible out here is defined by rules that are brutally strict. Every bit of speed you gained to get here, every push that carried you across that unimaginable distance, has to be undone. And undoing it is not just difficult. It is enormously expensive in terms of energy. You don't just need to move. You need to fight against everything that brought you here in the first place. And that turns out to be far more demanding than most people ever realize. So while you're still looking out that window, still staring at Saturn's rings, still trying to hold on to that initial feeling of wonder, there's another realization slowly creeping in. And it's not loud or dramatic. It's quiet, almost uncomfortable, like a thought you don't want to finish. The realization that this place, as beautiful as it is not just distant. It's isolating. It's final in a way that doesn't announce itself. But once you see it, you can't unsee it. And that's the strange thing I want you to sit with for a moment. Saturn isn't dangerous because it's violent or chaotic in an obvious way. It's dangerous because it sits at a point where the rules change, where coming here is one problem, but leaving is something else entirely. And by the time you truly understand that difference, you may already be too far away to do anything about it. All right, let's do this differently. Because if I just throw a number at you like 1 via billion kilometers, your brain is going to nod politely and then ignore it. And that would be a mistake. So instead, I'm going to ask you something strange. If you looked at Saturn through a telescope tonight, and I told you that what you're seeing is already in the past, not by seconds, not even by minutes, but by more than an hour, would that change the way you think about how far away it really is? Because the light leaving Saturn takes roughly 80 minutes to reach your eyes, which means even at the speed limit of the universe, it still feels like a distant memory by the time it gets to you. And that alone should make you pause for a second. Now take that idea and push it further, because seeing something is one thing, but interacting with it is something else entirely. Imagine you've finally made it there. You're orbiting Saturn, and you decide to send a simple message back home. Just a few words. We've arrived. That message doesn't instantly appear on Earth. It travels slowly, relentlessly, taking over an hour just to get there. And then you wait and wait again, because the reply takes another hour to come back, which means even the simplest conversation turns into a multi-hour delay, like trying to talk to someone across time itself rather than space. But here's where it starts to become uncomfortable, because communication delay is just a symptom of something much bigger. Saturn isn't just far, it sits at a distance that breaks your intuition completely. On average, it orbits the Sun at about 1 billion kilometers. And I know that still sounds like just another big number. So let's tear it apart properly. Mars, the place we're seriously planning to send humans in the near future, can come as close as about 55 million kilometers. Saturn is roughly 25 times farther than that, which means every single challenge we talk about with Mars radiation, isolation, limited supplies, you don't just face them again. You amplify them by a factor that your instincts are not prepared to handle. And I want you to really sit with that multiplication, because it's not linear in terms of experience. A mission to Mars takes around 6 to 9 months, which already pushes human endurance in ways we've never fully tested. Now stretch that out to Saturn, and suddenly you're not talking about months anymore. You're talking about 6 to 7 years just to get there, assuming everything goes perfectly, assuming you launch at exactly the right moment, assuming your spacecraft performs flawlessly the entire time. 7 years inside a machine, surrounded by nothing but empty space, watching Earth shrink until it disappears completely. Not metaphorically, but literally, until it becomes too small to see. And if that still feels abstract, let me bring you back to something more grounded, something almost absurd in its simplicity. Imagine again that car, driving at highway speed, 100 kilometers per hour, never stopping, never slowing down. To reach Saturn, you would be driving for more than 600 years. Not you. Of course, because you would be gone long before that. But the journey would continue, generation after generation, a chain of people inheriting the same drive, the same road, the same destination. And even then, they would still be somewhere out there, not quite there yet. So when people say Saturn is far, what they really mean, whether they realize it or not, is that Saturn exists at a scale where human experience starts to break apart. Time stretches, communication fractures, and distance stops being something you can imagine as a path and starts becoming something closer to a barrier. And once you begin to see it that way, once you truly understand that you're dealing with a distance that light itself struggles to cross quickly, you start to realize that getting there isn't just a journey. It's the beginning of a separation so extreme that turning back is no longer just a decision. It's a completely different problem altogether. Now let's assume something bold for a moment, just to keep this thought experiment alive. Let's assume you've already accepted the distance. You've made peace with the idea that Saturn is unimaginably far. And somehow against all odds. You've committed to the journey anyway, because this is where most people make a quiet mistake in their thinking. They imagine space travel as a kind of extended trip, long and difficult, sure, but still just a matter of time and patience. And I want you to see why that picture completely falls apart the moment you leave Earth behind. The journey to Saturn is not just long. It is relentlessly long in a way that changes how you experience time itself. Because you're not talking about weeks or months anymore. You're talking about 6 to 7 years just to get there. And that number only holds if everything goes exactly right. If the planets align perfectly, if your trajectory is optimized down to the smallest detail, and if nothing, absolutely nothing, goes wrong along the way, 7 years inside a spacecraft, and I don't mean a comfortable environment like a home or even a long-haul flight. I mean a closed system. A machine where every drop of water you drink has been recycled countless times, where the air you breathe has to be constantly regenerated, and where every resource is finite in a very literal sense. I want you to picture what that actually feels like, not in a dramatic way, but in a quiet, day-to-day reality. You wake up, you exercise to keep your body from deteriorating. You monitor system, you eat, you sleep, and then you do it again, and again, and again, thousands of times, with no real change in your surroundings, no new environment, no fresh air, no horizon to look at, just the same interior walls and the same endless darkness outside your window. And while all of that is happening, Earth is slowly disappearing behind you, not symbolically, but physically shrinking until it becomes just another point of light, indistinguishable from the stars around it. But the monotony is only part of the story, because out there, beyond Earth's protective magnetic field, you're no longer shielded from what space really is. Deep space is not empty in the way people imagine. It is filled with high-energy particles, cosmic radiation that moves at near light speed, constantly passing through your spacecraft, through your body, interacting with your cells in ways that accumulate damage over time. And the longer you stay out there, the more that damage builds, quietly, invisibly, without any immediate sensation to warn you that something is going wrong. Now add to that the fact that you are completely cut off from immediate help, because any message you send takes over an hour to reach Earth, and any reply takes just as long to come back. Which means that in any situation that requires quick decision-making, you are effectively on your own. There is no real-time conversation, no instant guidance. No one who can step in and fix a problem for you. Every system failure, every unexpected situation, every mistake has to be handled by you and the small group of people with you, using only the tools and knowledge you brought along at the start of the mission. And here's the part that I think people underestimate the most. It's not just the physical challenges. It's the accumulation of all of them over time. The isolation, the confinement, the constant awareness that you are moving farther and farther away from the only place you have ever known, combined with the knowledge that turning around is not as simple as it sounds. All of that builds into a kind of pressure that doesn't explode, but slowly weighs on you day after day until it becomes part of the background of your existence. So when we talk about the journey to Saturn, we're not just talking about distance or duration. We're talking about an environment that steadily strips away the assumptions you carry with you from life on Earth until you're left with something much more raw. A situation where survival depends not just on technology, but on your ability to endure a kind of isolation and exposure that humans have never truly experienced before. And that, more than anything else, is what makes the journey itself such a brutal and unforgiving path. Now, I want you to forget, just for a moment, everything we've talked about so far, the distance, the time, the isolation, because none of those are actually the hardest problem. And that's the part most people get wrong. You can imagine longer missions. You can design better life support. You can even train people to handle extreme isolation. But there's something sitting underneath all of that, something far more fundamental. And it doesn't care how determined you are or how advanced your technology becomes. It's a simple idea, almost deceptively simple. And yet it traps you the moment you try to leave Earth. Every kilogram you want to move through space has a cost. And that cost grows in a way that quickly becomes impossible to manage. Let me walk you through this carefully, because this is where intuition completely breaks down. If you want to send a spacecraft to Saturn, you need fuel to accelerate it to a high enough speed. That part sounds obvious. But here's the catch. The fuel itself has mass, which means you also need fuel to move the fuel. And then that additional fuel needs even more fuel to move itself. And suddenly, you're no longer dealing with a simple addition. You're dealing with something that grows exponentially, something that spirals out of control the moment you try to scale it up. This is what's known as the rocket equation, and it is one of the most unforgiving relationships in all of physics, because it doesn't bend to creativity or optimism. It just quietly enforces its rules. Now, I want you to imagine trying to solve this problem in the most straightforward way possible. You think, all right, if I need more speed, I'll just add more fuel. And at first, that works. You get a little more velocity, a little more range. But very quickly, you hit a wall where adding fuel stops helping and starts making things worse, because the extra mass demands even more fuel, which adds even more mass. And before long, the numbers stop making practical sense. You end up with a spacecraft where the overwhelming majority of its mass is just fuel. And even that isn't enough to achieve what you need. This is why space engineers had to come up with something that feels almost like a trick. Instead of carrying all the energy you need, you borrow it from planets. This is called a gravity assist. And it's one of the cleverest solutions we've ever predumally, because it allows a spacecraft to gain speed without carrying additional fuel. The Cassini mission, for example, didn't just go straight to Saturn. It took a long looping path, swinging past Venus twice, Earth once, and Jupiter once, each time stealing a tiny bit of momentum, building up speed step by step until it finally reached its destination after 7 years. But here's the important part, and I really want you to focus on this. Cassini was a robotic probe, relatively small, around 600 kilograms, with no need for life support, no food, no water recycling systems, no radiation shielding designed for humans, no living space, no medical equipment, none of the things you would need to keep people alive for years. The moment you try to turn that mission into a human one, the mass explodes. You're no longer sending a machine. You're sending an entire self-contained ecosystem. And every additional system adds weight. And every kilogram of that weight feeds back into the same problem. You need more fuel to move it. And this is where the trap really closes, because it's not just about getting to Saturn. You need fuel to slow down when you arrive. Otherwise, you simply fly past it. You need fuel to stay in orbit. to maneuver, to adjust your trajectory. And if you even dare to think about coming back, you need another massive reserve of fuel for the return journey. And all of that return fuel has to be carried with you from the very beginning, which means you needed even more fuel at launch just to move that future fuel. It's a chain reaction with no clean exit, a problem that compounds itself until the numbers become so extreme that they stop being engineering challenges and start becoming hard physical limits. So when people ask, why can't we just go to Saturn and come back? What they're really asking, without realizing it, is why can't we break the rules that govern motion itself? And the answer is simple, but not satisfying. You can't, because those rules don't negotiate. They don't care about ambition or curiosity or the desire to explore. They just sit there quietly, defining what is possible and what is not. And once you understand that, once you really see how the rocket equation traps you in this escalating demand for energy, you begin to realize that the journey to Saturn isn't just long or dangerous. It's fundamentally constrained in a way that makes the idea of a round trip start to feel less like a plan and more like a paradox you can't solve. Do you know what the strangest part of going to Saturn is? It's not that space might kill you instantly. It's that it probably won't. And that's exactly the problem. Because if something destroys you right away, at least you understand what went wrong. But out here, what happens instead is something much quieter, something that unfolds so slowly that you might not even realize it until it's already too late to do anything about it. I want you to imagine waking up one day during the journey, not at the beginning, not when everything still feels exciting, but years into the mission, somewhere deep in space where Earth is no longer visible, where time has stretched into something repetitive and almost meaningless. You feel normal, or at least normal enough. Nothing dramatic, nothing urgent, just a subtle sense that your body doesn't quite respond the way it used to. Like something is slightly off but hard to pinpoint. And that's where this really begins. Because space doesn't attack you in obvious ways. It rewrites you. Every second you spend out there, your body is being exposed to an environment that it was never meant to experience. And the changes don't come all at once. They accumulate. Take radiation, for example, not as an abstract danger, but as a constant presence, an invisible background that never turns off. High energy particles are passing through your body continuously, interacting with your cells, altering structures at the microscopic level. And the unsettling part is that there's no alarm system for this. You don't feel DNA being damaged. You don't feel mutations building up. You just continue living your routine while the effects quietly stack on top of each other. Now here's where it gets more uncomfortable. Because while that invisible process is happening inside you, something much more tangible is happening to the structure of your body itself. Gravity, the thing you've relied on your entire life without ever thinking about it, is suddenly gone. And without it, your body starts making adjustments that seem logical from a biological standpoint but become disastrous over time. Bones begin to lose density because they're no longer under load. Muscles shrink because they're no longer needed in the same way. And this isn't a temporary effect. It's a continuous adaptation, one that pushes your body further and further away from what it was designed to be. And I want you to really picture this, not as a scientific fact, but as a lived experience. Months pass, then years, and the changes keep building. Your skeleton becomes weaker, your muscles thinner, your heart less capable of handling stress. And none of this happens in a single moment that you can react to. There's no clear point where you say, this is where it went wrong. Instead, It's a gradual drift, like a slow transformation that you are aware of but cannot stop. At the same time, your brain is dealing with something just as serious. Radiation isn't just affecting your body, it's affecting your ability to think, to make decisions, to process information. And that's a dangerous combination when you're operating in an environment where every choice matters. Memory, reaction time, judgment, all of it can begin to degrade. Not catastrophically at first, but enough to matter, enough to introduce small errors that can cascade into bigger problems. And then there are the subtler effects, the ones that don't sound dramatic, but become critical over long periods. Fluid shifts in your body change the pressure in your head, affecting your vision, sometimes permanently. Your immune system weakens, making you more vulnerable to infections that would be trivial on Earth. Even viruses that have been dormant in your body for years can reactivate under the stress of this environment. Healing slows down. Resilience drops. And over time, all of these factors begin to overlap, reinforcing each other in ways that make recovery harder and harder. So by the time you approach Saturn, after years of exposure to this environment, you're not just a traveler who has endured a long journey. You are someone whose body has been fundamentally reshaped by space itself, not destroyed, not in a dramatic sense, but altered in ways that are difficult, maybe impossible to reverse. And that's the part I want you to really understand, because it changes how you see the entire mission. The danger of going to Saturn isn't just that you might die out there. It's that you might survive long enough to arrive, only to realize that the version of you that made the journey is no longer the version that could ever come back. You finally made it. After years of travel, after everything your body and mind have been through, Saturn is no longer a distant object in the sky. It fills your window. Massive, detailed, almost unreal in its scale. The rings stretching out like thin blades of light, elegant and silent. And for a moment, I want you to just stay there, looking at it, because this is the moment most people imagine when they think about space exploration. The arrival, the achievement, the proof that the journey was worth it. But here's the part that changes everything. And it's so simple that it almost feels unfair. There is nowhere to go, because Saturn, despite how solid it looks from a distance, is not a world you can land on. It's a gas giant, a vast sphere of hydrogen and helium with no true surface, no ground waiting for your feet, no place where you can step out and say, "We're here." If you tried to descend into it, you wouldn't land. You would sink deeper and deeper into layers of gas that become denser, hotter, and more violent, until the pressure alone would crush anything we could possibly build. There is no dramatic touchdown, no safe arrival. Just a gradual transition from orbit into destruction. So maybe you adjust your expectations. You tell yourself that landing was never the goal, that orbiting Saturn is enough, that studying its moons, its rings, its atmosphere is still a success, and in a scientific sense. That's true. You could look at Titan with its thick atmosphere and lakes of liquid methane, or Enceladus with its geysers of water ice hinting at a hidden ocean beneath the surface. And there is real value there, real discovery. But even as you focus on that, something else is waiting in the background, something you can't ignore forever. At some point, you have to ask a simple question: how do you leave? And this is where the illusion finally collapses, because getting to Saturn was only half the problem. And in many ways, It was the easier half. To arrive, you needed to accelerate to build up enough speed to cross that enormous distance. And then you needed to slow down just enough to be captured by Saturn's gravity. That alone required an enormous amount of energy. But leaving requires you to do it all over again, in reverse, and with even less margin for error. You need fuel to break free from Saturn's gravitational pull, fuel to accelerate back toward Earth, and then fuel again to slow down when you get there. And all of that fuel had to come with you from the beginning, carried across billions of kilometers, because there is no refueling station waiting for you out here, no rescue mission that can reach you, no backup plan once you're in orbit. Every kilogram of return fuel made the journey to Saturn harder, heavier, more expensive, and even then, it still may not be enough. And this is where the mathematics becomes impossible to ignore. The rocket equation doesn't relax just because you've already come this far. It still applies, just as strictly as before. And when you run the numbers for a round trip, they don't just become difficult, they break down completely. The amount of fuel required grows so large that the spacecraft you would need stops being something we can realistically build. It becomes something closer to a moving city, a structure so massive that launching it from Earth would be a challenge beyond anything we've ever attempted. So now you're there, orbiting Saturn, surrounded by one of the most beautiful sights in the solar system. And at the same time, you're facing a reality that is impossible to avoid. There is no landing. There is no rescue. And most importantly, there is no simple way back. And that's the part that changes how you see the entire journey. Because arrival, the thing we usually celebrate, is no longer a conclusion. It's a point of no return, a moment where everything that came before it, the years of travel, the engineering challenges, the risks you accepted suddenly takes on a different meaning. You didn't just reach Saturn. You placed yourself in a position where leaving may no longer be an option. And once that realization settles in, quietly but completely, the beauty outside your window starts to feel a little different. So after everything we've walked through, the distance that stretches beyond intuition, the years of isolation, the fuel that traps you in its own logic, the slow transformation of your body, and the realization that even arriving doesn't solve the problem, I want you to step back for a moment and look at the bigger picture. Because this is where the story stops being about Saturn and starts being about something much more fundamental. It's very tempting to think of all these challenges as temporary, as obstacles waiting to be overcome by better technology, smarter engineering, or more determination. And that instinct makes sense, because that's how human progress has worked for most of our history. We see a barrier, we push against it, and eventually we find a way through. We climbed mountains that once seemed unreachable. We crossed oceans that once looked infinite. We even left our planet and stepped onto the moon. And each time, the impossible slowly became possible. But what makes this different, and I want you to really feel this distinction, is that the limits we're running into here are not just practical. They are physical. They are written into the way the universe works. And that changes the nature of the problem completely. Because when something is limited by physics, it doesn't matter how badly you want it. It doesn't matter how much effort you put in. There comes a point where the rules themselves define what can and cannot happen. Take everything we've discussed and look at it through that lens. The distance to Saturn is not just large. It is large in a way that forces long travel times and extreme isolation. The rocket equation is not just inconvenient. It creates a compounding demand for energy that grows beyond manageable limits. Radiation is not just a hazard. It is an unavoidable consequence of leaving Earth's protective environment. Microgravity is not just uncomfortable. It systematically reshapes the human body over time. None of these are separate problems that can be neatly solved in isolation. They are interconnected effects that reinforce each other, forming a system of constraints that becomes harder and harder to escape the deeper you go. And this leads to a conclusion that may feel uncomfortable at first, because it goes against the way we like to think about exploration. A human mission to Saturn, with any technology we can realistically imagine in the near future, is not just difficult. It is effectively impossible as a round trip, not because we lack creativity, not because we haven't tried hard enough, but because the requirements push us into a region where multiple physical limits converge at the same time. Now, could that change someday? Possibly. You could imagine propulsion systems far beyond what we have today. Nuclear fusion engines that provide vastly greater efficiency. Advanced shielding technologies that protect against radiation. Spacecraft capable of generating stable artificial gravity, or even entirely new approaches we haven't conceived yet. And if those breakthroughs happen, the picture might look very different. What is impossible today could become merely difficult in a distant future. But here's the part I want you to hold on to, because it's easy to miss. Even if technology advances, the laws of physics themselves do not change. You're not removing the limits. You're finding new ways to operate within them. And there may always be destinations that remain just out of reach. Not forever inaccessible, but inaccessible for beings like us, with bodies and lifespans and biological constraints that were shaped by a completely different environment. And that brings us to something deeper, something that goes beyond engineering or science. Because when you look at Saturn from that perspective, it stops being just a destination we can't reach and starts becoming a reminder that the universe is not built around our abilities or our ambitions. It exists on scales of distance and energy that dwarf everything we are. And while we can explore parts of it, we are still bound to a very small corner of it in a very real way. There's something almost humbling about that. And I don't think it's necessarily a negative thing. We often measure progress by how far we can go, how much we can conquer. But maybe there's also value in recognizing where the limits are, in understanding that some boundaries are not meant to be broken, at least not by us, at least not now. Because when you accept that, when you see Saturn not as a failed destination but as a natural boundary, it changes the way you think about where you already are. This small planet, this place we sometimes take for granted, becomes something else entirely. Not just a starting point for exploration, but a rare environment where everything we need to exist comes together in a way that may not be easily replicated anywhere else. And maybe, just maybe, the fact that we can't simply leave and go anywhere we want is not a limitation to be frustrated by, but a perspective that reminds us how extraordinary it is that we are here at all, on the only world we can truly call home,